Hello and welcome to Azure Mert to the Future. Sorry about the long break, but we have a very special guest today. And Eve Pardi, welcome to the Azure Mert to the Future. How are you?
Thank you so much. I'm feeling really great and I'm really excited about this talk today because I think this is the first time I am here at this show.
Yes,
And so very, very happy for thank you a lot for the invitation.
you are welcome and thank you accepting my invitation. I am very excited to having you here and also very excited to talking about AI today. And before we start your presentation, can you introduce yourself?
Of course, thank you so much. And thank you again for letting me talk at this show. It is really a great honor. I am Eve Pardi, a Microsoft AI MVP and Advanced Analytics Consultant at Avanade. I am the owner of AI 42, which aims to teach newcomers to the field of AI. And I'm also a member of the Global AI community, which is organizing different events all around the world to connect those who are interested in AI. You can reach out to me on Twitter and Facebook as well. And just a few words about myself and my focus points. My aim is to save lives and support humanity with AI and data and make people understand how intelligent applications affect our lives, how to use and control them. And when you're ready, I get going with my presentation. So in the last few years, artificial intelligence has become more and more prevalent and powerful. And many speeches around AI nowadays explain how these technologies can be benefited to predict stock prices and create value for an organization. And in fact, even the online courses that are meant to educate newcomers in the field are focusing on the financial benefits of AI. So in today's materialistic world, I'd like to focus on how the very same technologies can be benefited to predict natural disasters and eventually increase survival rates and improve quality of life. The disasters caused by natural phenomena have been present all along human history. Nevertheless, their consequences are greater each time. And this tendency will not be reverted in the coming years. And on the contrary, it is expected that the natural disasters will increase in number and intensity due to the global warming. According to world statistics, the increase in the number of disasters between the decades of 1987 to 1996 and 1997 to 2006 was 60%, going from 4,200 to 6,800. Whereas the number of dead people during these periods increased 100%, and it went from more than 600,000 to more than 1.2 million. And more than 9 million Australians have been impacted by a natural disaster or extreme weather event in the past 30 years. And the number of people affected annually is expected to grow as the intensity and, in some areas, the frequency of these events continues to grow. And in Australia, the total economic cost of natural disasters is growing and will reach $39 billion per year by 2050. And these costs include significant and often long-term impacts like social impacts, including death and injury, as well as impacts on employment, education, community networks, health, well-being, and I could go on. And humans have been trying to predict earthquakes at least since first century China, when they used this device like a jar with metal dragons facing each compass direction, surrounded by frogs with their mouths open. And if the ground shook somewhere in the region, the metal ball in the dragon's mouth would drop out into the frog's mouth, roughly indicating the direction of the earthquake. And many similar predictions actually sounded reasonable, but after some research, those things were concluded to be natural phenomena with little to no correlation to earthquakes. AI, however, solely relies on data. And multiple researchers are creating their own applications to predict earthquakes and aftershocks. Moreover, these systems also monitor aging infrastructure, so AI can detect deformations in structures, which can be used to reduce the damage caused by collapsing buildings and bridges or subsiding roads. And During this talk, you will see a real-life example of saving more lives with AI, how to examine a natural disaster, and how to use that observation to save more lives, while you will also get a good overview of how Azure Machine Learning Workspace works. And now let me show you a story that motivated me to use AI to save more lives. In April 2015, there was an earthquake with 7.8 magnitude and an epicenter in the Garka district of Nepal. And this disaster killed almost 9,000 people and injured 22,000. And this horror, in most cases, was caused by the collapsed buildings in the earthquake. Many data scientists have been working very hard to improve the survival rate of the next disaster. And our mission is to build a predictive machine learning model to investigate and understand the risk of damages in case of another natural disaster. And the result of our findings is available for mitigation of which buildings might need strengthening when another earthquake comes. And by this, not only the memorial buildings and homes could be saved, but also thousands of lives. I was talking about data scientists, but what is data science? Data science is really just an umbrella term. It refers to figuring out ways to study and solve problems with data. And to do that effectively, you need a range of skills like computer science, mathematics, statistics, and whatever domain you are in, you need expertise in that domain. So, for example, for this project, you might need to understand architecture and some kind of forecasting of natural disasters. So data scientists are absolutely obsessed with data. And the first thing we always do if we have a problem to solve, that we are looking around for all the possible data sources that we can bring to bear on the problem. Then we have to figure out how do we acquire the data, like how do we get into some system like data warehouses, Databricks, or maybe Azure Machine Learning Workspace. But of course, the data never arrives in the shape what we hoped for, so we might need to spend a lot of time on transformation, cleaning, reshaping, and so on. And then we need to understand the relationships in the data, like what is the data trying to tell us about a problem we are trying to solve? Which are the features or variables that actually seem to be useful, or which are the ones that may just add noise to the situation. And then finally, we are going to do some predictive analytics or machine learning modeling. And through modeling and the results we generate, we hope to deliver value back to our customers or end users, which helps them drive decisions or make their decisions a little better. And I often see a little confusion around the term machine learning and AI. So let me try and clarify these, how these are connected to each other. So artificial intelligence is a technique that enables computers to mimic a human intelligence, and it includes machine learning, which is a subset of artificial intelligence. Then machine learning includes techniques such as deep learning, which are neural networks that permit a machine to train itself. And with machine learning techniques, we can enable machines to improve at tasks with experience. But how a machine can be trained? Learning can be defined as the process of knowledge acquisition. And humans learn differently, but all involve experience. And while humans have the ability to reason, computers don't have that ability. Therefore, they learn through algorithms. So we can talk about unsupervised, supervised, and reinforcement learning. Unsupervised learning is an example of, imagine that I'm giving you some information saying 1 yellow Eva, 2 green Mert. And then the machine is going to try and find the patterns in this data. And it has to understand that, okay, I got some numbers, I got some colors, and I got some names. And then based on this information, in the next time when it gets some information, it will be able to handle that accordingly. In unsupervised learning, we don't have labeled data. But in supervised learning, we generally include a set of labels along with our data, along with our features. And in this case, the algorithm generates a function that maps inputs to desired outputs. So that is an example of that. I am giving you some images of apples, and I also give you a label for these images saying apples. Or I'm also giving you some images of bananas and with the label stating that it's a banana. And after a while, our machine may be able to decide whether it looks at an image that is about an apple or a banana. Whereas reinforcement learning is where the algorithm learns a policy or how to act given an observation of the world. And every action has some impact in the environment, and the environment provides feedback that guides the learning algorithm. This technique is, by the way, used very commonly in autonomous driving or game development. So, machine learning models generally have an iterative nature involving four subsequential stages. So, please let me sketch you up the main steps you need while you train your machine learning models. So, first of all, we need to prepare our data. We pull in the data into some system and prepare it for training. And data can come from various sources. Generally speaking, in machine learning solutions, the more reliable the data, the better. So then we need to explore this data, which is going to allow us to understand the data set and its structure. And after the data set is understood, and then irrelevant observations can be removed, as those would only add noises to the data set. For example, duplicates can be removed to avoid biased models, or missing values should be handled because otherwise it's not usable by the algorithm. And then finally, we are going to do some splitting on the data for training and testing. The next step is to do the training of the model, which basically starts by choosing which specific algorithm we want to configure our model with. So the raw data is first transformed into features that the model can understand. And then after the goal of that model has been clarified, the right algorithm must be selected. And typically, machine learning problems can be solved in many, many different ways. Therefore, multiple solutions can be developed and compared throughout the iterations for getting the best fitting models. And it is often difficult to choose the right algorithm, but I will show you some tools today which might help you to make this decision. The next step is to do the scoring of the model. This is the process of generating values based on a trained machine learning model. And the generic term score is used rather than prediction because the scoring process can generate so many different types of values like list of recommendations, numeric values, a predicted outcome, and so on, depending on what kind of data you provide or how you train your model. And then last but not least, evaluation of the model, which basically is metrics that tell you how good your model works. For example, the accuracy of a predictive model would mean that how well does it predict the future? And this is a never-ending process. And when we find some issues during evaluation, like our model doesn't work well enough, we possibly need to go back to do some further feature engineering and some hyperparameter tuning to achieve a better performance. And now, what we want to do is to build a predictive model which is able to answer our question from the data we provide: which buildings are in danger when another earthquake comes? And while we were talking about analytics, we could identify many different types of the predictive from the analytics, but predictive analytics deal with designing statistical models or machine learning models that predict. And these models are calibrated on past data, like experience data, including features and labels. And then the machine learns from these examples and then predict the future. And teaching a machine might sound like some kind of black magic, but thanks to the tools provided by Azure, you have the chance to easily get started with machine learning and learn about the different training algorithms and then understand what the result tells you with the use of Azure Machine Learning Workspace. So, What is Azure Machine Learning? And I think before I continue, I quickly ask out if we have any questions for the things we have just heard about.
And I have some questions, but it might be a little early. Do you want me to ask now?
If it is related to this part of the topic, then it may be better to answer yes.
Yes. To use Azure Machine Learning, how can I start? So, do I need to know data science, or do I need to know machine learning, or it's just a tool? What is Azure Machine Learning, by the way?
So Azure Machine Learning is a web experience that brings together all kind of data science capabilities and machine learning assets into a single web pane. And the cool thing about Azure Machine Learning is that it is available for every kind of skills. You don't need to be good at coding necessarily. You don't need to know by heart which algorithm works best for what exact scenario, because it is going to support you a lot. Let me show you around so maybe you get some answers on your questions.
Okay.
So the Azure Machine Learning Workspace is considered as the top-level resource for Azure Machine Learning, providing a centralized place to work with all the artifacts required to build your solutions. And this workspace keeps like history of all your training runs, including logs, metrics, outputs, and snapshots of your scripts as well. I would like you to take a look at the capabilities of this tool. So I would like to start by showing you the portal.
Okay. I will make it
Uh,
full screen. Okay.
Yeah, you are welcome to make it full screen, sure.
Okay.
So to get started on Azure Machine Learning, you first of all need to create a resource. And that you can do if you have an Azure subscription. So if you go and create a new resource, we can say we are looking for an Azure Machine Learning. And we say click create. And all you need to do is to define which resource group you want to put your workspace to. We give it a name. And please note that storage account, key vault, app insights are generated for you together with your workspace. Storage accounts is going to be used to store the related data for or your scenarios. Key vaults are used for security reasons, and app insights is for monitoring the performance of the workspace itself. You are welcome to create your container registry at this point, but otherwise it will be generated for you when it is ready to be used. Until that, it's not really needed. Otherwise, it might be a bit costly. On the next step, you can set up whether you want to disable public access and use only private endpoints. And then you can also define how should one have access to the assets of the workspace. And then after you can review and create your workspace. And after deployment, you can go to the dashboard and simply launch the studio from here. And when you do that, this is the workspace that you're looking at for the first time. And you can see all kind of assets and all kind of tools that you can use here. And I would like to start from the bottom. And first, I would like to show you around on the compute. So you can create a new compute here with memory optimized CPUs or GPUs as well. You just provide a name. I give it something special. Oh, that already exists. That's not very special, but this is not cool. And then you can choose whether you want to go with CPU or GPU. And in the advanced settings, you can add startup and shutdown schedule, which is very useful. I tend to forget to switch off my compute and it can become very costly. So it's a good idea to set up a schedule as well for your compute.
So, may I ask a question?
Yes?
So, what's the difference between the CPU and GPU?
So a CPU is enough for analytical statistical calculations. GPU is better used for deeper algorithms, for example, image processing. So CPU is enough for most of the tabular data analysis and in some text analysis cases as well. But for higher compute requirements, I would suggest to use the GPU instead.
Okay, thank you.
I thank you. All right. If we go to linked services, you can connect different Azure services to your Azure Machine Learning workspace, like Synapse, for example. And in here, in the data labeling, you can create labeling projects with image classification or object detection. And if we go to the assets, we can take a look at the data here. And here you can import data into the workspace, so it's available for you to use in your pipelines. And the data you can, I just quickly show you, I give it a name just to show you how does it look. You can upload data from a web file or some open source pages. You can upload it from your own PC or from Azure Storage as well. And these data sets are versioned. So let me show you. So you will always see the latest version, of course, but you can version it however you like. If you make some changes, then it will always have a newer version, but you are welcome to go back to whatever version you want to work with. All right, if we take a look at the Explore tab, then we will have a little overview of our data. We can see that we have building ID, some age, area, height, and so on, a lot of demographical information about the buildings. And this data set holds around 260,000 buildings. And these buildings are the ones that have been collapsed during the past earthquakes in Nepal. And in the end of the data set, we can see this will be our label column. But just by looking at this tabular information here, that doesn't tell us much. So let's take a look at the profile. And in the profile view, we can see nice statistics about each of the columns. And as an example, let me show you the age column. If I click on it, I get some details as well, a plot that is showing the mean and where the data is, how the data is distributed, and so on, and all the quantities and all the details about the age column. And what we can see here, and I would like you to note that the youngest building is 0 years old, but the oldest one is 995. This was a memorial building that has collapsed also in the earthquakes. Another interesting column that we can look into is, for example, the position column, which is holding string values. But here we can also still see that the most common value is S, and we have 4 unique values in this column. And it also returns you an information about whether you have missing information. Another nice observation that you can take is with the has underscore columns. About that, there are a lot. It is like giving you an information about what are the materials that has been used for building this structure. So as an example, we can see a minimum value is 0 and a maximum is 1. We could expect that this might be a true or false value. And to be sure, all you need to do is to take a look how many unique values there are in this column. And we can see that we have no missing values. And thanks to this information, now we can be sure that this is Boolean information, so either true or false. Then let's take a final look at our label columns. I just scroll down there quickly. So the label columns is going to be used in the prediction as this is the information that we need to figure out with our machine. So we will have a bunch of features, all those columns that we were looking at as an example, and we will have this label column. This is what we will need to predict. And what we can see here, the lowest, the minimum information is 1, which is the low risk of damage. The highest one is 3, which is going to be a high risk of damage. And there are label 2, which is medium risk of damage. And we can see that the most common value is the number 2, which is the medium risk of damage. And this is quite a problem, because the best case would be if these numbers were closer to, these would be closer to each other, though it is visible that the number 2 has much more examples than the label 1 and 3. And the problem here is that if the model is trained on more examples with label 2, it more often returns the label 2, so the medium risk, even when the risk is supposed to be high or low. All right. Let me go to the next one. The next asset is the jobs. This is where we will see all the runs when we, want to run an experiment. So when you build your models, then this is where you can monitor the run of them. In the components, we can see our custom components. These are created as building blocks for your machine learning project, which is a self-contained piece of code that does one step in a machine learning pipeline. And these components are building blocks for advanced machine learning pipelines, and these can do all kind of tasks like data processing, model training, model scoring, and so on, whatever you like. Then the next one, environment. No, this is the pipelines first, sorry. So the pipelines, this is where you can see the available pipelines for your job, and these can be triggered from connected services as well, from, for example, signups. And now I get to the environments eventually. These are different setups that contain several already installed packages, and rest assured that you would find your favorite ones here too, like TensorFlow, Scikit, PyTorch, and so on. In the models, you will see the deployed models. And at the endpoints, this is where you will reach your deployed models. So you can deploy your models into Azure Container Instances or Azure Kubernetes Service or FPGA, or to an Azure IoT Edge device as a module. And here, these endpoints are dedicated endpoints for a deployed model, where you can leverage the capabilities of your deployed model through an API call in your application. And before I continue, I would like to go back to my slide for a sec and show you around the next tools. Because when you are unsure which model fits best your dataset or solution, the no-code UI of automated machine learning is the first you should try out. And it allows you to easily create accurate models, customized to your dataset and refined by different algorithms and hyperparameters. You can use algorithms like deep learning algorithms for classification, time series forecasting, text analysis, and you can see there are a lot more. So you can simply download the best model and improve it in your own PC too. And by pressing the deploy button, your model is ready to use from an API endpoint. And you can also review your model fairness and get a good explanation by using the explanation dashboard. And there is an Azure Machine Learning, the Automated Machine Learning SDK, which allows you to trigger an automated machine learning run from your own PC too. Now let me show you how this works. I'm going back to the Azure portal. There we go. And even though you are, again, unsure about what to do, all you need to do is to go to Automated Machine Learning and say Start Now. And you can just create a new automated machine learning job. And what you need to do is you need to choose a data set. Here you can have a quick glance on your data again, just like we had in the previous section. But let's close this one and we go next. And in the next step, we will create a new experiment. Let's call it AutoML2. And we need to choose the target column. Here we need to choose the label column, which is the damage grade, because we still need to figure out which buildings are maybe in danger. Then we figure out which compute this run should go. And then we click next. And the smartness here is so great. What is happening here, what you're looking at right now, is that automated machine learning just received a data. We provided a column. And by looking at the data and the column, as a first view, automated machine learning tells you that you should go with classification, because classification is used when you want to decide between several categories. For example, in our case, the low, medium, or high risk of damage. And if you enable deep learning, then you will get better results, better accuracy for your model. And when you click next, you can choose whether you would like to use 10 or other percentage validation data. And you can also upload your test data if you like. And when you click finish, your run will be initialized. And after that is done, it is going to start running different algorithms. And if you take a look at this run, look at the models. You see it has tried a lot of runs here with different models. And on the top of all this, the best one is shown that returned with 81% of accuracy. And what we can do here is that we take a look at this model. And the first thing that I would like to show you is that you can download your code from here. And you can do further improvements which can be applied on your model before deploying it. And you can easily deploy your model from here as well by clicking only on this button, really. And if you want to learn more about your model, you could take a look at the metrics as well, where you can visualize all kinds of details. For example, my favorite one is the confusion matrix. It shows you how confused is the model. For example, let's say the true label is 1. So in 1,000 cases, it's correctly predicted that that building has only a low risk of damage. But in 45 cases, it predicted that that building should get high risk of damage, whereas it was just low risk of damage. So this shows how confused is your model. All right, I go back to my run. And in the overview, AI systems have a growing impact on people's lives on an everyday level. So it is fundamental to understand models, protect people, and control your AI systems. And our models can behave unexpectedly for a variety of reasons. So fairness and interpretability tools can help you understand the behavior of your data and your systems so that you can better tailor them to your needs. And if you take a look at the data guardrails, we can see the information that it's found unbalanced data. And it is alerting us that there is some problems with our data. And unbalanced data is really a big problem. And we might end up turning our model unfair. So the solution for this problem we will see at the next demo. But now I would like to go back to our models and give you an overview how to explain your models. You can just look at the explanations panel here. And it is still in preview version, but at least it gives you some information. So on the first tab, we can evaluate the performance of the model by exploring the distribution of the prediction values. And we can select filters along X and Y values to cut across different dimensions. And please note that this is based on only 5,000 rows now of the data set. Yeah. And the Dataset Explorer also provides statistics about the model performance on the next tab. And you can also choose different filters. You can also change the graph type on the right side. Oops, if it works sometimes, yes. All right, let's just go back here. And you can also find out the important features at the Aggregate Feature Importance tab. And these are the features that impact the overall model predictions. And you can use the slider on the top to show higher or lower number of importance values of the features. And I show a feature, this one. And here, this dependence plot shows the relationship of the values of a feature to its corresponding feature importance values. The next step, individual feature importance, and this allows us to drill into an individual data point and their individual feature importance. For example, you can load the individual feature importance plot for any data point by just clicking on the individual points in the scatter plot here. And then the feature importance plot shows the important features for the individual predictions. So in other words, you get an explanation of the local behavior on a specific data point. And you can deploy this explainer along with the original model and use it as an inference time to provide the individual feature importance values for any new data point during production-ready solutions. And if you want to learn more about how your data has been transformed, you can see that in the Data Transformation tab. And you can see how your data has been used. All right. Let me now go back to our slides. Do you also have the situation when the manager walks up to you and asks, how long time do you need to build a machine learning model? And you will start asking questions, and then finally you might get some data, and then the aim of the model is also finally clarified. And I don't know about you, but then my first step is to put together a quick POC, which is then ready to present while saying, this is the flow of the model, and it is now ready to estimate the length of deployment and development works as well. And then we can go ahead and use a rich set of built-in components for data transformation and preparation, model training, scoring. You can basically build an end-to-end pipeline with the use of Designer with a drag and drop interface in which you only need to specify the different parameters for the components. And this is a great way to show an easy to understand visual workflow about how your complex machine learning training pipeline works. And you can automatically generate scoring files, which is ready to be shared with your clients. So before we take a look, I think we have a question. So do Azure Machine Learning has ability to explain the model by SHAP values? That is a great question. I need to come back to that question later if that is all right. So let's take a look how the designer works. I'm going back to my machine learning workspace, and I go to designer and start a new pipeline, just like that. But you see, there were some, okay, just go back quickly to that one, because see, there are some built-in solutions already ready to use if you just want to try them out. But you can build your own pipeline with the use of the drag and drop interface, where you can see all kind of amazing components ready to use. And these are all built in, ready for text analytics. You can write your own code with these components here, and you can write Python and R, and you use anomaly detection if you like. So it is ready for you to go ahead. And when you build your pipeline and you run it, it will be visible in jobs. And when it has been finishing the run, you can also see all the components that has been used for your specific run. And if you want, you can just go to that place exactly. It's also opening up the details, which I don't want to show, but at least it shows that, okay, this is the component that you were looking for. So what I did first, I pulled in the data set, this data set that we have used for all the other demos as well. And this was, you know, the information that we have observed in about the different buildings. And so what we want to do is this model should define which buildings might need strengthening before another earthquake, and to exclude noisy values like the ones that doesn't bring any good information into our model. And we can select the columns in the data set with this component. And another important component is to normalize the data, because you can exclude outlier values like we have seen, for example, at the age column. And the goal of this normalization is to change the numeric values in dataset to use a common scale without distorting differences or losing information. And this is really useful since most of the columns have different metrics with different scale. For example, age, height, and these all have different scales, right? And now all the columns will be on the same range of values. I can show you how ugly does it look like when it's done. See, it is very ugly when it's finished. But that is what we need now. All right. And the challenge of working with imbalanced data sets in most machine learning techniques is totally ignored. And in turn, they have a very poor performance. But although if you think about it, typically the performance on the minority class is also very important. And in our case, the high risk of damage is a minority class, for example. So what I'm doing is I'm using the SMOTE approach. And with the help of this approach, I can provide a model close to equal number of samples of the labels. And when I get the data together again, maybe before I do that, I show you quickly how did it look like before. So after normalization, Let's see. Go to my damage grade column and see this is how many examples we have of the label 1. This is the example of the label 2 and examples of label 3. And after I did the SMOTE and I get the data together, come on. And what I would like you to see is that they eventually get a bit closer to each other. So I go to the end of the thing and look at this. This is how it looks now. These are quite closer, right? And now finally, we have a very nicely featurized data, at least ready to go finally. Then what we do is that we split the data for training and testing. And then I also chose an algorithm to train our model with. If you use the tune model hyperparameters, then it is going to be able to provide you the best fitting parameters for the data and algorithm you use. And then we go and score the model, which is basically going to do the prediction for us. And I just visualize you the results. And it is going to show you the chosen damage grade for a specific building and also the confidentiality of choosing the specific categories. So this is the chosen category, and here are the confidentiality for the specific scores, for the specific labels, sorry.
And we have another question.
Yes. How Azure Machine Learning treats missing values. Do missing values drops or interpolate those missing values? Great question. I missed that step. There is a clean missing data component here that is configured by you. It's like it is going to do whatever you prefer. It can, yes, remove the rows if that's what you prefer, but it also tries to, it also provides you opportunity to make changes on that specific row. Let me find that for you and show you quickly how does it look. Clean missing data. So you can choose the cleaning mode, and that cleaning mode has its own parameters. So it is like one of the, this is a very custom value now that you provide a range to it, what should be the value range, and then it is going to be updated like that. But you're welcome to make these changes for yourself. For example, you can choose to replace with mean, median, mode, and so on. All right. So after scoring and doing the prediction, it is very important to do the evaluation of your model, because this is what is going to tell us how well our model works. And if you take a look at the evaluation results, you can see that our model is 80% sure about its decision as soon as it opens up. But thanks to all these built-in modules, you can quickly build an experiment and find out by incremental trials which setup works best for your scenario. And when you're happy with the model, it can be deployed and used in production too. And another cool thing that I would like to show you quickly is that the scored data set can be downloaded from the storage, and then you can send that to the organization that works on improving these constructions. So hopefully these findings save more lives as well. And if you would like to further work on your results, you can register the data as well. And these results are going to go into your storage, and you can use them as data sets. And you can do that at any step in your pipeline. All right, with that, I would like to quickly show you around the last component, because Microsoft also provides us an easy to use, and it probably is familiar to many of you, code-first environment, the Azure Machine Learning notebooks. And you can alter your models, transform, and prepare your data with Python or R. And these notebooks also uses pre-configured, up-to-date machine learning packages, and whatever we as data scientists need to save time on setup tasks. And you can also automate designer or automated machine learning experiment runs, or you are welcome to use your favorite developer environment, even on your own PC. So let me show you how this one works. So I'm going back home here, and I say, actually, I have it open here. Great. So in this notebook, you can see, I'm not sure if you have worked with the Jupyter notebooks, for example, but this is a very similar setup. You have your folder structure with all your files in it, and then you can use the compute instance that is ready for you here. But you can create your own compute as well from the notebooks. Remember to stop your compute when you're not working on it, because again, it can be quite costly. So what we first do here is that we check the SDK version number. This is really great idea because when you find an issue, then you easily find an answer based on the SDK information. Then we initialize the workspace, making sure that we are connected, and then we create an experiment. This is where our run will work on. So we create a compute and then prepare the environment where our experiment should run in Docker. And we also define how the compute target should look like. We define the size of it, how many nodes it should have, and so on. And then we create the script that is going to run. And the script, there is an entry script for this that is holding all the steps of our run. This is going to be an automated machine learning run. It is starting by splitting the data set and then getting the training data set, prepare that data, do some featureization, and then after that, it is going to do the training as well, defining the algorithm, build the pipeline, and then do the training, calculate the results, and then use that results to be returned. So with all this information, we are ready to run our pipeline. And after the completion, we can get back the metrics. And I didn't run now because it takes a while until it finishes, but I can show you the result. The data set I was using was a balanced data set already. So what I did was, this is the one that was generated with the code I just showed you. And if I come here, take a look at the data guardrails, see everything looks fine, we don't have unbalanced data. And if you take a look at the model results, we get 93% accuracy from this model. And if you can take a look at the explanation for this, then we again get the information of the features that we have used. So we are sure that our model is fair and it's understandable how it works. We can take a look at the very specific information of how the data has been transformed. We can review the metrics again, possibly the confusion matrix, which gives you a lot of information. And it is now, it's not 1,000 correctly predicted label 1, but 11,000, which is really great. All right. And you can also get the code generated for you from here. So it's not like you need to write yourself everything. What you can also do, if we go back to the model, and then we can take a look at the generated code. And you can test your model from here, straight in this workspace. And there is a new feature called Explain Model, which is going to provide you even deeper information about how responsible is your model. Okay, so with that, I go back to my slides, and I can see that we have a question. So do the trained model in Azure Machine Learning can be used as pre-trained model in other environments such as Jupyter, or can it be deployed in Docker to use it in other applications? Yes. The one that you create in Azure Machine Learning, it can be with automated machine learning or the notebooks as well, but with the designer easily, you can mostly deploy it to Kubernetes and container registries, FPGA, IoT, and of course, together with all the packages that you require in your Docker environment, as you can see in my code. All right. So I think with that, I would like to tell you a few words about some information that you can find also, because we are getting towards the end of the session, but this doesn't have to be the end of your journey with Azure Machine Learning Workspace. And you can read more about what is Azure Machine Learning on the first link, and you can find the code and data set for the solution I was just showing. Also, the blog post is available on codewithdeep.azurewebsites.net, which is going to be shared as well later on. And probably I will keep updating it with all the new information that is not there yet, possibly. If you want to read about how to create your own components for the designer, you can read about it on the last link. Do we have any questions?
I have a question.
Yes.
So, Microsoft has another solution for machine learning.net.
Yes.
And we have some solutions on Azure, like Azure Machine Learning Studio and others like cognitive services. And how can we choose the correct service or tool when we start an machine learning project?
It has to be a very, very complex decision, because what you need to decide also is that what is your expertise. Because if you are better in, for example, .NET languages, then better than in Python, or you are not really a programmer, that these are all factors when you make the decision. For .NET people, of course, ML.NET is the go-to solution. For those who are not really a programmer or not really familiar yet with data science and AI, then of course Azure Machine Learning Workspace is a get started tool. And for those who would like to use already prepared solutions, then it's cognitive services, of course. But all these the cognitive services and Azure Machine Learning Workspace are not just for those who don't really know where to get started. That is also for advanced projects too. Because, for example, I know that cognitive services, the custom models, and so on are leveraged at many, many customers today. And we get a lot of nice feedbacks from it. The same with Azure Machine Learning Workspace.
Okay, thank you. So, do you have any recommendation for the people who starts new to machine learning?
If you're just getting started with machine learning, I would say that you might want to go to AI 42, where you will get some information about what is the fundamental knowledge that you might need while you build your machine learning models, because you will hear about mathematics, some statistics, all kind of programming languages are presented there, all kind of tools that you can use for your experiments. And I think that's a perfect platform to get started. Because together with AI 42, you will eventually have a chance to try out the different services available for data scientists and machine learning engineers. So yeah, that's one place to go.
Okay, and following you on social media and your blog posts, right?
Yes, that's also a good idea. And of course, I'm always open to help if there are any questions. So feel free to just ping me when you have anything in mind.
Okay, thank you very much for your presentation. It is very informative, especially for me.
Yes,
And
I thank you.
hope to see you in further episodes or different
Yes.
topics.
That would be amazing. And I really thank you for your attention. And I really hope that you found this session beneficial when you build your next AI solutions. It was a great honor to be a speaker at your show.
Okay,
So thank you.
thank you very much. Thank you. Okay, so anything to add, or do we have any questions? No. Okay, thank you very much, and have a good evening.
Yes, you too. Bye
Okay,
bye. Bye, everyone.
bye.
Thank you.
Cheers.